So thanks again for joining the session, guys. So in the last session, we have talked about pre-processing and labeling using Amazon's SageMaker on production scale. See, again, I keep repeating the word production, right? This is very important because if you want to do without production level or at scale, you can do it on a simple notebook, and that's not a big deal, right? Like we have all done that using Jupyter notebooks. That's not a big deal. So our focus is primarily building systems at production scale. When I say production scale, it could be anything. Like if you're starting from, let's say, 100 megabytes of data all the way to gigabytes or terabytes or petabytes or whatnot, right? So you throw more compute, you can do. So that's why this is called distributed computing, and we are talking about production scale. So if you remember last session, we were talking about processing. If you haven't seen that, please go and check the last session. It's on YouTube, right? So this session will primarily focus on deployment and REST endpoint. Okay. So what is deployment mean? Deployment means, so let's say you built a great model. Okay, the model is doing fine, it's giving great results, but how do you get users to use it, right? So you have to, like, there are few ways of doing it, is doing the deployment or making your model usable. The first way is what is called as batch predictions, wherein this is what we usually do in Jupyter Notebook, right? So in Jupyter Notebook, when we just give some testing, whatever, that's basically giving a bunch of values and you get a bunch of results, right? So that is primarily a batch sort of system, wherein you're giving, data in batch, and then you get results in batch, right? So that's the way it works. But obviously that scale is very slow, very low. SageMaker also has batch prediction functionality at much higher scale. Okay. In fact, I would say if you're going to design a system architecture for machine learning projects, you have to carefully weigh in what should be the batch prediction, what should be the real-time prediction. There's something called async. Okay. So basically, our streaming prediction. So there's REST endpoint, there's streaming prediction, and there's batch prediction, right? So we discussed about batch prediction already. So let's discuss about streaming prediction. So what happens in streaming and REST is you're basically getting real-time predictions, right? Real-time predictions meaning, let's just say you go onto YouTube and search something, right? You're getting some results. And by the way, those results are very relevant, right, to the search word and all that. How does it happen? In the backend, there is the ML algorithm that is running. Okay. Now, when you go and type it there, you get results pretty quickly, right? So what is happening is Google is already storing a lot of potential search results using batch prediction, as well as sometimes they will do real time also. It's very complicated. I mean, it's basically it's pretty complicated, right? I mean, I'm not going to say I know exactly how it happens, but they use a mix of both. That's how they are able to give you very relevant and very fast. Okay, that's what corporates look for. They want very relevant and pretty fast. All right. So having said that, let's just talk about these, the actual mechanisms, and then the use cases we'll talk in the next series. The next series we're going to do about machine learning system design, wherein we're going to take a problem like, let's say, YouTube searching or something else or whatnot, right? And then we'll discuss how you actually want to build architecture. That is actually the most in-demand skill right now. Okay. So with that said, let's just jump into this. So today we're going to talk about REST endpoints. What are REST endpoints? Basically, the use case of REST endpoints is giving you reliable predictions in near real time. Okay. So essentially, when you send a JSON object as a payload to this REST endpoint, you're going to get a result back, a prediction back at near real time, right? Whereas batch is not real time, but it is much more cheaper to do and much more, you can do any amount of scale. Whereas the issue with the real time endpoint is if you want to get a lot of scale, then you end up spending a lot of money because you have to. It's like a premium service, right? So it gives you the guarantee of real fast response, but it is costly to do it because you're going to use up high performance compute instances and all that. Okay. So with that said, let's get started. So this is how a typical architecture of a real-time endpoint will look like, right? So we've got, feel free to ask me any questions you've got, right? So what you see here is basically you got you know, an architecture diagram for how this happens, right? So typically it starts with your training data that sits in something like S3 bucket. Then you do model training. By the way, the model training we will do in the next session, right? Model training is pretty complicated. I need like a full hour for that. Since we don't have time, we're going to do it next time, right? So basically, you have data, then model training, and then you basically come up with a model, right? And you're going to deploy that model in a model registry, right? You can deploy it in a model registry, or you could put it in something like S3 bucket or whatever, right? Again, we'll discuss about what model registries in a later point of time. But let's say that you have a model now that is sitting in, let's say again an S3 bucket, right? Ultimately, every a so-called artifact or data usually sits in S3 bucket and gets pulled from that, right? Now, so you're going to take this model which is sitting in an S3 bucket or a model registry. You're going to deploy it on a endpoint inference machine. So everything in SageMaker or in general AWS is an instance, right? Yeah, TG. Yeah, please tell me your question.
Krishna, the question is related to S3 bucket, whatever you have highlighted, that what the data will be stored in S3 bucket. When the data is petabytes, does the S3 bucket will sustain? I think it should be Snowflake, something like that.
Okay. Actually, S3 bucket is the most reliable, highly scalable, more cheaper option than even Snowflake. Okay. Snowflake, the use case is you want to do some sort of processing. That's what Snowflake is used for. Having said that, there is a competition to Snowflake versus Databricks and BigQuery or whatnot, right? But S3 is the most reliable scale storage solution for petabyte or whatever scale, basically. Like it's the most basic object. Okay, it's the cheapest, most reliable, most used storage system in the world right now, because AWS has the highest share in the computing world, right? S3 is the backbone of everything that is done by AWS, which means most amount of world's data today probably stays in S3, right? So in that sense, it's extremely reliable, extremely industry friendly, because it's already so entrenched in the system, basically. Yeah. Any further questions?
Yeah. The other point is with respect to the buckets, whatever.
Will predefine.
Sorry?
Am I audible?
Yeah, you're audible. Tell me.
Okay. As you conveyed, sorry, the data and the information will be predefined in the Google. Okay, whenever you give any information, you will get the information spontaneously. For example, in Google, when we do search for any information, right? So it means the process of information is predefined and indexed.
Not necessarily. That's what I'm saying. That's a complex architecture, right? Some part of what you see on a Google search or a YouTube search is already pre-computed. The word is pre-computed. Okay. Yes, it is pre-computed. Let's say most of it is pre-computed, but some parts are computed on the fly. All right. So they use a mix and match system to get you the best user experience at the cheapest cost possible as per their internal discussions. Let's say for a given search, they want to give you extremely highly relevant results, which means they have to get the results like last minute or so, isn't it? Sometimes Google does get you results which are like a minute old or 5 minute old, right? For that, they can't do pre-computations. Okay. So for that, they have to do real-time inferences, which is costly, by the way. So they have a trade-off sort of situation. So for some search results, some YouTube videos or whatnot, they'll do pre-computations. For some, they'll do a mixture of both. For very few, they'll do real-time inferencing. I mean, again, I'm not an expert, but this is my best guess possible, right? It's kind of close. It's almost like 90% true. Again, we'll discuss these things in the next coming sessions in detail. All right. So for now, let's just focus on this point, which is basically how an inference happens on a REST endpoint, right? So now we just talked about the model artifacts, sitting in an S3 bucket, right? And essentially from the S3 bucket, it gets deployed onto a inference instance, okay? So in AWS and SageMaker, they have instance classes. So essentially for inference, they have a special class. You have to take a permission to get that in a quota and all that. So they don't let you use any type of instance for every function. They have that restriction, which means you have to make sure you're using the right instance for the right functionality. That is also very important. Again, we'll discuss about in the last video in slightly more detail, so please check that. Now, having said that, so you have an inference instance on which you have deployed a model. Okay. Now the model is let's say ready to take predictions. Okay. So what happens is basically let's say you have some sort of client application. It could be a website, it could be something else. Essentially, you're calling an API, right? So basically the REST endpoint is getting called, and then some data is being passed, and then there's computation happens on the instance, model, the inference instance, and then results are given to the client application. That's what we are basically depicting in this architecture diagram, right? Now there's something else here. So essentially there's also a bit of some training that happens. Basically from the user interaction also, you can actually take some information and use it to train basically your model, right? That's what actually Google does, right? So if you see and observe, right? If you observe when you use Google Maps and go to a location, at the end of it, the Google will ask you, hey, have you reached your destination successfully or not, right? So when you say yes, that information gets recorded and it is used for better labeling of their models. So in a way, Google is actually profiting of you, right? It's providing a service, but it's also learning. And that's what is called as data network effect, wherein it's getting better and better continuously. That's why it's very, very hard to compete with Google, right? Wherever these sort of feedback loops are there, they get better over time and they like beat everyone else. That's the data network effect, okay? So having said that, let's move on, okay? Now, so this is the code basically, this we have seen in the last session also. This is code that instantiates the session, you're defining a bucket, etc. So it's the same stuff like everywhere. And then we define a training job name. Now what we're doing is we're copying our model that we have. We'll be discussing about training in the next session, where how to create model and all that. So that is already done by me. So we're copying the model from that bucket location to the current directory. And after that, we're also checking, hey, what are all the different files and whatnot. This is just for a sanity check and all that. Now we're untarring the model file. Once I untar file, you see a whole bunch of things here. This is very important, right? So you've got an inference py, which is basically the actual application code that gets triggered through the API endpoint. Okay. Then you got a little bit of test data that you can use if you want to use that. There's other information about the model. There is some indexes, right? So these are all some TensorBoard stuff is there. So these will not cover right now, but you will cover them later, maybe in a TensorFlow course or something like that, right? No, so these are all the information that is there. So it's not just one thing. There's a bunch of things that come with as a model package, right? Now, once we have all of this, we can actually view what is in the model, right? This is a very useful for us. So if I scroll down, you will see that it's actually displaying the model architecture, right? I'm not sure how many of you know how deep learning architecture is basically, but it is showing you the architecture of the model here, right? So tensor specs, it is showing some bits of it, right? So we have different layers and all that. So that is all getting listed here in this model, right? Now, this is another same function. It is basically running the model, and then we are getting a signature. We are trying to host it on like a TensorFlow server, right? More like just to test and to see if things are working. Okay, it's like a small POC on the instance, and obviously we have gotten something. Okay, so which means it's working on that local machine sort of thing. Okay, now this is the inference code that is packaged in as a part of the model itself, right? So when we untar the model, we've gotten this code from that, right? Again, this is very important because this code is what is going to be taking the data and doing an inference. Okay, so let's quickly walk through this. Okay, so we've got a distill BERT tokenizer. We've explained why we are using that in the last session. So we're using distill BERT, then uh, doing a bunch of computation there. We've got input IDs, attention mask, input masks, right? All these things we discussed in the last session. Um, then we've got an output handler. So essentially, you take a JSON, right, in the form of text, because we are talking about reviews, right? You take text in the form of JSON, then you output results in the form of JSON itself, and the JSON, the output would be rating, right? So is it good? In our case, it's 1, 2, 3, 4, 5. 5 being very good, 1 being pretty bad, right? That's a classification we are doing here. So you're going to respond in a JSON format itself. That's the whole this code. That is the whole point of this code. Okay. So now we are taking this code, the inference.py, and we are taking the model, and we are basically putting in the instance machine, right? That's what we're doing here. Okay. Now we want to again give a model name. Like I said, this is a good convention to use date timestamp, because that way you get a uniqueness to your artifacts. Any of the artifacts you want to store or something, always use a date timestamp forward, right? Once you do that, you're attaching a training job name to our TensorFlow estimator. Okay. So here we're defining the instance type. This is important because usually you need to get a permission. I actually got a quota, so I can actually use this, right? This is the machine that is being used for instances. Sorry, the inferences. Okay. Now after that, you're defining a bunch of other parameters, right? And finally, you're deploying the basically you're calling deploy function, and you're deploying this, right, with the model and everything else. Okay. Now it's successfully passed, and it is saying it's deployed that basically model at that whatever REST endpoint. Now let's look at the REST endpoint. Okay. If you click this, you will go to REST endpoint. I've already clicked this. So this is the endpoint that you can see. All right. Let's look at this endpoint in slightly more detail. It's very, very useful and interesting. Okay. So now this endpoint is basically an inference instance, and it has got its own life, right? It's got its own statistics, metrics, and whatnot. So all of that are taken care by default, and that is why SageMaker is very, very useful and production friendly. Okay. If you're doing any sort of like inferencing on your local machine, you can't store all this data, right? So that's why it's not a recommended procedure. Okay. This is why SageMaker is useful. Okay, because it captures all this data. So you got the name, it's telling you uptime, and when is it created, when it was last updated. So in fact, if you have a new model, you can actually update the model while the instance is running. Okay, that's another useful feature. Okay. Now it's also showing you CPU utilization, memory utilization, disk utilization. Right now the CPU utilization is very low because we are not calling any models. So I'll show you, we're going to call a model, and then it's going to, like, the CPU utilization will just bump up a little bit. I'll show you that also. There are other metrics that are very useful. We're showing what is instance type, etc., endpoint configurations and whatnot, right? So all of these are useful information that is getting showed in the log page. Okay. Now let's go and test it. Okay, so we have an instance running. We're going to test it this time with some data. Okay, so these are all other things that are important. So it's just an ARN. What is ARN? It's like a unique identifier for every asset. Within the AWS ecosystem, every asset will have a ARN. That gives her like a unique identifier. Very useful, right? So there's some lineage tracking also. So if I run this code, I'm going to see like source and other things. Obviously, we have seen a lot more there. So this is all information useful. Now let's test the endpoint, right? Basically, this is a code. It's a predictor code. It's like instead of estimator, it's a predictor. So you're going to use this predictor to send some data, okay? And then you'll get a response. So in this case, I'm sending data like this is great and this is bad. Okay. Now this is the, let's say, review on an Amazon page or something, right? Now what are we going to get? That's what it depends here, right? Let's just run this and see. Okay, so for predicting for great, I'm getting 5, which is good. For bad, I'm getting 1, which is good, right? Because we said, let's try in one more feature. Okay, in real time. Let's see one more feature and see what happens. Okay, I'm going to say, okay, I'm going to say this is average. Let's say what it predicts for average. Okay, all right. I'm hoping it predicts like a 3 or something. Yeah, okay, so it's given 4. Okay, let's say below average. Yeah, it's given 2, right? Which is good, which means this is finally working, right? So the system is able to give a rating similar to a human, right? So you give a bunch of text, it's able to give you some rating which is somewhat relevant. This is the end use. This is the use case of using a machine learning model. Okay, I hope you guys can see the utility of this, right? So using this, we are able to do classifications quickly, and then based on that, we can do some other important useful things later on, right? That's the whole point. Okay. Now, remember we had this whole big testing file, right? We're going to run this, and then we're going to see, like, we're going to pick some samples from this, and then we're going to run and see, like, okay, what is that we're seeing? Okay. Let's look at that. Okay, along with the predictions. Okay, so this is the text basically. So it's saying I have had some issue or something, which is the tone is slightly negative. So I'm getting a 5. I love it. It's free and functional. So I'm getting a good 5, right? So you can add with a list of unsatisfied customers. So it's getting 1, which is fantastic. I mean, like, see, this is like machine is actually understanding English, right? I mean, it's like natural language processing, it's understanding. I mean, obviously, this is a lot of research, but it's a fantastic model, but still, this is literally magic, right? How come a machine is able to understand text, right, and give you accurate predictions, right? So this is fantastic. So let's run for slightly more, samples instead of just 10. Maybe let's run for 15. Let's see what happens. Okay. So you remember, like, when I said 15, it's gotten slightly slower, right? Because slightly more data. Okay. Now it did not work content like CS, right? Now it's showing see, you can see this. This is a rating given by the man, like a ground truth, which is predicted by human. This is the one from the machine. So almost matching, except here, right? So you're saying it's like 1, but so it's missing sometimes also. So that's how it works, right? Yeah. So basically, this is the end of the demo for how you do deployment in real life production settings and how you can actually get this. As you can imagine, using that API, you can actually put it in any of the machines, any of your code, and get real time predictions basically. And you can track the CPU performance, etc. You can do a whole bunch of things after that, which is basically, if you think the load is getting higher, you have auto scaling that you can enable for the endpoints. There's a load balancer that sits behind, so it'll take off all the load and all that. So it's very production friendly concepts are embedded into the SageMaker functionalities and all that. So that's basically the use case of how deployment works. The next sessions we'll discuss more about we'll discuss more about training. We'll also discuss about some interesting concept called pipelines. So basically, pipelines is the most advanced concept in production machine learning, right? So we'll discuss that maybe in the next coming sessions, where we talk in detail about pipeline. I think that will be a 1-hour session. So we'll be doing it in the next sessions. All right. So with that said, any further questions, or we will close the session.
Not from my end, Krishna.
All right. Okay. So thank you guys for this, for coming to the session. I hope you enjoyed this. We'll see you in the next coming sessions. Thank you all. Thank you. Bye.
Thank you. Good time ahead.